Lecture 13 covers section 4.6. At the end of today's lecture, you should be able to apply mesh current analysis to circuits with independent current sources, as well as independent voltage sources. For us to begin, we will analyze circuits that have N sub C current sources, and we will construct N sub C current equations relating each current source to one or more mesh currents that run through it. When we construct our mesh current analysis, the number of KCL equations we will need will be N, our number of meshes, less N sub C, the number of current sources. By doing this, we can construct a supermesh such that we need to evaluate one less KVL equation. If we do not use a supermesh, we will construct N KVL equations and apply a voltage drop across our current source. To begin, let's look at the circuit below. We have a voltage source connected to resistor R1, which is connected to resistors R2 and R3. R2 and R3 are connected to a current source I sub S. Say we want to construct an expression for a mesh current I2 in terms of our source current IS. To do such, we construct a loop where we trace out I2. I2 enters the current source opposing IS such that I2 would be equal to minus IS. Now let's look at a slightly more complicated situation. Imagine our current source is now placed in between resistor 1 and resistor 2. Now we have mesh current 1 and mesh current 2 both sharing IS. We recognize I2 is in the same direction as IS, where I1 is in the opposing direction of IS, such that our current output is going to be the difference of I2 and I1. That is, mathematically, we can say IS is equal to I2 minus I1. Now in this particular situation, we have something called a supermesh. A supermesh is where a current source is shared by two mesh currents. When we do mesh current analysis with a supermesh, we will apply a loop that spans our two mesh currents, bypassing our current source, and thus construct our KVL equation in terms of I1 and I2.